the gravitational potential, absolute potential energy, and the general form for the force is Gme, the constant of gravitation, mass of Earth, mass of the object by the radius of Earth squared. Okay, we start here and we approximate the average of the radius to the product of the first radius and the second radius between the 2 points. Yes. Okay, so I can get into that too, but it's better to not worry about that. But let's say if we have average radius, this is r1 plus r2 by 2, yes, and we derive the approximation. Delta r is r2 minus r1, which is very obvious in physics, and then r2 is equal to delta r plus r1. Yes, r1 plus delta r. Okay, so our average would be r1 plus r1 plus delta r by 2. Yes, we put r2 as r1 plus delta r, which becomes our average is equal to 2 r1 plus delta r by 2. Our average square would be 4r1 square plus delta r square plus 2r1 delta r, 4r1 delta r by 4. Yes, and we know the squares of the small terms like delta r square because it's very small, so we approximate it to 0. So what we have is our average square is equal to 4r1 square plus 4r1 delta r by 4. So our average is equal to, once again back substitution, 4r1 square plus 4r1 r2 minus r1. We substitute delta r, and yes, and we take 4 out, and this cancels, so our average square is equal to r1 square plus um, plus r1 r2 minus r1 square. Yes, so this becomes r1 r2, so our average square is now r1 r2 approximately after taking the approximation. So in the equation for force we put gmem by r1 r2 as the average radius square of the average radius, and now differential work from 1 to 2 is equal to uh, force into distance, which is yes, I will show you, just give me a second. So basically the case is that there is this earth, and we have this radius re, and then we have the radius r1, and then r2, and then up to r infinity. Yes, because we're raising the object. So This is how we actually approximate the absolute potential. So force is equal to GMEM by R1 R2, yes, and delta R is equal to R2 minus R1. So here is delta R, the step size, let's say, the differential displacement. So, and work done is equal to from 1 to 2 is equal to F delta R cos theta, and since theta is roughly equal to 0 degrees, so cos 0 will be 1. So what we have is differential work from 1 to 2 is equal to F delta R, and is equal to GMEM by R1 R2, and now we have here R2 minus R1, yes. So you see what we're left with is differential work from 1 to 2 is equal to GMEM by GMEM into R2 by R1 R2 minus R1 by R1 R2. Okay, so this is differential work from 1 to 2 is equal to GMEM into 1 by R1 minus 1 by R2. Yes, so this is from 1 to 2. And similarly, from 2 to 3, or let's say from differential work from 1 to n, 2 to 3, 3 to 4, and whatever, the differential works would have a similar general form, with the first radius here and the second here, 1 by R1 minus 1 by R2, then 1 by R2 minus 1 by R3, and basically differential work from n minus point n minus 1 to n, yes, would be GMEM mass of the object, mass of the earth, gravitational constant, by 1 by Rn minus 1 minus 1 by Rn, yes, and the total work would be equal to the summation of differential works from 1 to n, and that would actually cancel out many factors except the first and the last. So what we are left will be equal to so summation differential works, total work would be equal to GMEM by 1 by R1 minus 1 by Rn, yes, and if the last point is far away, we can put it as Rn is equal to R infinity, yes. So the total work would be, in this case, GMEM to 1 by R1 minus 1 by infinity, which is 0. So basically we are left with GMEM by R1, yes, the first radius, and this is the work from I will tell you. From infinity to 1, work from infinity to 1, work from infinity to 1. See the last point is infinity here. We start with R1, then go to R2, and then we go up to infinity, which is very much the absolute potential energy. So GM by RE, which is approximately the radius of the earth here, starting from the center of the earth. So this is once again the approximation. R1 is equal to radius of the earth. So we get the absolute potential energy. So we discussed the torque in the case of electromagnetic circuits. See, so torque, yes, and we will draw a simple schematic which shows the direction of forces 1, 2, 3, and 4.